If you're new to this channel, you may consider subscribing and hit the bell icon so that you continue to receive the updates. Also, after watching this video, you may want to refer to some of the playlists that we have created for people who are interested in in-depth knowledge. These are the videos in the right sequence, which will give you thorough knowledge of the subject. Please share it with all others who might benefit. Let's get started.
Now let's talk about the word cloud. And if you see, to get the word cloud, we'll have to do an installation of the word cloud library. We'll just have to do that first, and then we can use the word cloud class. It says requirement already satisfied. Let us just finish, then we'll be able to run the rest of the code. So from word cloud, we are importing this word cloud class, and we're also calling matplotlib because we'd want to create some kind of a visualization. We're defining a function called make word cloud, which will take the input as the text, and the output would be a word cloud that it generates. So we're using this specific function called word cloud. We are giving some dimensions like 800 by 400. This is the height and width. We are giving a background color that's white. We could change it to any other color. And we are giving collocations as false. So it essentially would avoid putting the words together. It would identify the words as single entities. If you use collocations is equal to true, it's going to take those words together which are used together in your text. And then there's a color map scheme that we're giving. This dot generate text essentially accepts the input. And then we are giving it a figure size. We are giving it an IAmShow. IAmShow essentially is from matplotlib. It'll show the word cloud and doing an interpolation bilinear. And we are putting the axes to off and doing a plt.show. Now here's the text that we're giving as an input for this word cloud, which talks about natural language processing. So we have a couple of sentences here together, and it'll try to represent them in a word cloud form. Let me just run this and try to give this input as the text to the make word cloud function that we've defined above. And let's see what's the word cloud like. So if you see, this is how the word cloud is. You might have seen many word clouds earlier as well. So it essentially is a very simple representation where the font of a word is decided based on its frequency. So something that comes up as a theme would be given a higher font size. Something that's used once or twice or very limited times, it would be given a relatively lower font size. In this particular case, we didn't have too much text, but if you have a lot of text, like maybe a book or maybe a few pages, it makes a lot of sense because it's able to capture the theme. For example, if you're, let's say, analyzing the data from X, people have been writing comments about something that's happening, and you want to find out the key theme out of it, you can quickly create a word cloud and get to know what is it that people are talking about. Let's say you're buying something from Amazon and you want to see the reviews of those who have not rated it too well. So if you're some way able to filter the text and apply a word cloud on that, you'd get to know, let's say, why a particular cell phone model is not being liked or why it is being liked. You'll get the key theme through the word cloud there. Next, we move to bringing the text to a format where it can be given as an input to a machine learning algorithm. Now let's talk about the count vectorizer. So count vectorizer essentially is going to give us an output, which would be like a document term matrix. You know that from the theory, that it's going to give us the count of words, the number of times a word has been used in a specific document or an input. So let's say we're creating a simple data frame, which has a column called review, and it has these entries. The product is great. The second entry is not recommended, terrible experience. Third entry is highly recommended, amazing quality. Very simple data. And we are putting this dictionary inside pd.dataframe. This is the easiest way to get a data frame. Then we are instantiating this count vectorizer, which we've called from sklearn feature extraction text. And then we are doing a fit transform on the review column of this data frame. When we do this fit transform, it generates a sparse matrix. Now, that is something which the pandas data frames would not accept as input. So we have to convert that to an array or to a dense format. In this case, we are doing it to array format. And then we can give it as an input to pandas data frame. We are saying columns will be vectorizer.getFeatureNamesOut. Now this getFeatureNamesOut is very useful because it'll create the data frame with appropriate names. And what will be the names here? The names will be these terms or words. Let's run this and see what's the output that we get. So this is completed. We've not really printed anything out, but let's just say we want to see the original data frame now. It was just one column, review, and you had these three feedbacks there. And what does the count vectorizer do? See. So this is how the count vectorizer has worked. It has brought in that unstructured data to a structured format. So in our overall text, the word amazing was used once, and that was in the feedback index 2. The word experience was used once, and that was in the feedback index 1, so on and so forth. So this is more like a row column kind of a data that we are used to of, and this is what most of the machine learning algorithms expect as the input. So this kind of is a simple demonstration. Please note we have not done stop words removal and all here because this was more to give you a basic idea about how an unstructured text can be brought to a structured form. When we take up a case study, we will of course be talking about performing all these steps as the prerequisites, and then we'll come to the counter-vectorization stage. So let's talk about the TF-IDF. TF-IDF, pretty much like the counter-vectorizer, is something that you can call from scikit-learn feature extraction text. And we've given a little longer text here at this time, a set of couple of sentences. In fact, it's a list of these sentences, as you can see. We're pretty much doing the same kind of syntax. We are not applying too many hyperparameters because we are just doing basic text preprocessing. TF-IDF vectorizer, though, has a couple of interesting hyperparameters, which can allow us to filter the words based on certain inputs, but we are not talking about that right now. We are just doing a fit transform, and the input here is this list of sentences, as we saw. We are again using the get feature names out. This would ensure that the feature names would be as per the words used here. And then we are converting it to dense. So we can do it to array or to dense. If we are creating a data frame, the input cannot be a sparse matrix. Remember, this fit transform would convert the data to a sparse matrix. Sparse matrix is a matrix which has a lot of zeros. We are saying we'll not straight away be able to give that as input to the pandas data frame. We will instead give a dense matrix. So to array or to dense would do one and the same thing for us here. We can use either. And then we are mentioning the feature names as per this get feature names out. Finally, we are going to look at the output of the data frame. Let's see. So here's the output. This has 51 columns. Again, we did not really remove the stop words and do other cleanups here to begin with. So it's kind of showing all the words the way it sees in that overall text. And what is this row representing? These are different entries. These are different sentences in that list of documents that we saw. This time we did not give the input as the specific data frame. Instead, we gave the input as a list containing multiple sentences. So you have this output, and TF-IDF, as you can see, because of the kind of calculations it performs, it gives values which are more into decimals and all, and will again have a lot of zeros. That's by nature is going to be somewhat sparse. The same code essentially is repeated below, where we just did an experiment of to dense or to array. It'll be giving you the exact same output. You can run that on your own. This is one and the same. It doesn't give you an error. So to array or to dense, they give you similar output. There are some nuances, but we don't really have to worry about it right now. So with this, we kind of get a basic understanding of how we bring the unstructured data to a structured format. Hope it helps. Now let's understand, why do we need to learn NLP? There is a growing demand of NLP expertise across various industries. Companies are actively seeking for professionals who can develop applications like chatbots, sentiment analysis tools, and virtual assistants to enhance customer experience and automate tasks. Advancements in AI and machine learning. NLP has seen significant advancements in recent years. Thanks to breakthroughs in artificial intelligence and machine learning, the availability of powerful computing resources and large data sets has enabled the development of more sophisticated NLP models, such as transformer-based models like GPT. Rise of conversational AI. Conversational AI powered by NLP is becoming increasingly prevalent. Businesses are integrating chatbots and virtual assistants into their platforms to provide instant customer support, automate the routine tasks, and improve user engagement. Influence on search engines. Search engines are incorporating more advanced NLP techniques to provide more accurate and contextually relevant search results. Understanding NLP can be beneficial for those involved in content creation, search engine optimization, and digital marketing. NLP is increasingly integrated into everyday applications, ranging from email filters and language translation services to social media platforms. Learning NLP can empower you to contribute to the development of such applications or customize existing ones. Applications in data analysis and insights. NLP plays a crucial role in extracting meaningful insights from vast amounts of textual data. As organizations continue to generate and collect large volumes of text, the ability to analyze and derive insights from this data becomes a valuable skill. So here were some quick reasons for you to have the motivation to learn natural language processing. As we progress through this journey, we'll be talking about all these steps in sequence, how you start with a very basic data that you convert into a meaningful form and try to make sense out of it. The journey has just begun.